Hi guys, so we are back again. So just we will not linger on introduction any longer. In the last classes, we have already explained that is what is the technique of this means making videos and uploading in YouTube channel, and it's I'm trying my level best to make the concepts clear to you. So if you have any problems, you can contact me. Already I told you in the last meeting also. So before delaying means without delaying any further, I will say that we have already discussed about in the couple of last few videos. We have discussed random variable, discrete continuous random variable examples. We have done little small sums. Then probability mass function, discrete distribution. Then we have solved problems with that. We have then learned the properties of distribution function, and we have also solved problems with that too. Finally, we have started expectation of a discrete random variable, and we have also solved problems with that after studying the properties of expectation. Okay. So now we go to the next topic that is written on the means heading variance and standard deviation of a random variable. Okay. So we should know that what is actually meant by variance. Okay. So please go to page number 69. I've already sent you the pages in your WhatsApp group. So please go to page number 69. Okay, I start reading from there. If you don't follow that page, you will not be able to understand. Okay. So variance and standard deviation of a random variable. The variance of a random variable, capital X, denoted by var X, is defined as, see, this is var X. That is equal to, we have to find the expectation of something, which is nothing but x minus m the whole square. Okay, where m is equal to expectation of x. Okay, now please don't ask me what is e. Okay, in the last video already this has been explained. So those who don't know what is e and how to find out the expectation, please refer last video. Okay. So we have to find out now for this, if we want to find out the variance of this particular random variable, capital X, okay, then we have to first do Ex, okay, then we have to store the value of Ex inside another variable called M, then I have to do X minus M whole square, and then on this particular term, I have to find out the means expectation. So this will give me the variance of the random variable capital X. Is it clear? Is it clear? Okay. Now this is the definition of variance. And what is the definition of standard deviation? The positive square root, page number 69 again. The positive square root of var X. Now if you do square root of var X, you get positive and negative values. We just choose the positive value. Okay. The positive value of square root of var X is called as the standard deviation SD of capital X, and it is denoted like this. So you shall be using these terms in pattern recognition also. Sigma capital X, or sigma X, or simply sigma. These are the three notations you can use for standard deviation. Okay. So let's start again. So what is var X or variance of capital X? That is, first find out M, that is expectation of X. It's explained in the last video. Then do X minus M the whole square and find out the expectation of this entire term, X minus M the whole square. That gives you the variance of the random variable capital X. Okay. Now do the square root of var X, and they will get you will get two values, positive and negative. Just choose the positive value, and that gives you the standard deviation of this particular variable capital X. Okay. And how do we actually write standard deviation? We can write it as sigma X, or sigma suffix X, or simply we can write it as sigma. So is this portion clear for all? Up to this, is it clear? Next, I go to this part. Remarks. The variance describes how widely the probability masses are spread about the mean. So expectation means mean, explained in last video. That is, it gives an inverse measure of concentration of the probability of the probability masses about the mean, which is called the measure of dispersion. Okay. All these are not so much required for your class pattern recognition. Means whatever is required, we just only follow up to that. Okay. So, var x will become equal to 0 only when capital X minus m is equal to 0. That means capital X is equal to m. So, in this case, the whole mass is concentrated at the mean. Okay. So, we will have var x equal to 0 only when capital X minus m is equal to 0. Just look at the formula of variance. We have just written, just before this, we have written. So we will get var x equal to 0 if and only if capital, what is var x? That is expectation of capital X minus m the whole square. Okay, and you know how to find out expectation. Don't have to repeat. So if this capital X minus m becomes 0, then var x will become 0. If this x is equal to m, if x minus m is equal to 0, we will have x is equal to m. So what it means? This means that the whole mass is concentrated at the mean. Okay. The whole mass is concentrated at the mean. What is m? M is Ex. Just right now we have Ex means what? The mean. Okay. And so means or the expectation. So if capital X is equal to m, this means the entire mass, it's not spreaded, it's concentrated at the midpoint, means at the mean. Okay. Now we study some theorems on expectation. Okay. Now remember, note guys, that these are all based on random variable. Okay. Yes, these are all based on random variable, discrete random variable. Next we will go for continuous random variable, that is later. Now we focus mostly on discrete random variable. So let's concentrate on the theorems. You don't need the proofs, just you have to remember the theorems. So theorem number 1 says var x, look in your means WhatsApp group, page number 69. Okay, repeat this one, means repeatedly. That is equal to e over of x squared minus m squared. Okay, that is equal to e over of x squared minus, now m means itself ex. We have just right now learned that m means itself ex, so it will become ex the whole square. So this is theorem number 1, very important theorem. What it is? Var x is equal to ex square minus m square, that is equal to ex square, expectation of this term x square, minus expectation of x whole square, because m means expectation of x, so m square means expectation of x whole square. Remember, there is a difference between these two. This is e over of x square, means you are finding out the expectation of this entire term x square. Okay, you are finding out the expectation of this entire term x square, and this is different. This is expectation of x you are first finding out, and whatever value you are getting, you are squaring that. I repeat myself, this is first we have x square and we are finding out expectation of x square. Okay, and this is first you find out the expectation of x. Okay, and whatever value you get, you square it. There is a difference between these two, are not same. These two are not same. Okay. Now my theorem number 2 is var ax plus b, that is equal to a square var x. This is my second theorem. Var ax plus b is equal to a square var x. This is my second theorem. Okay, ax plus b. So this becomes a square var x. Theorem number 3. Where k is equal to 0, where k is a constant. A was also a constant. Okay. This is theorem number 3. So these are the 3 theorems. Theorem number 4 is not necessary for now. So these are the 3 theorems you have to remember. First one is already written. The second one is where ax plus b, that is equal to a square where x, and the third one is where k is equal to 0. Okay. You don't need the proofs. Straight away go to page number 70 now. What is written over there? Moments of a random variable. Okay. Please start reading it. The rth moment, page number 70, the rth moment of a random variable capital X about A, denoted as mu r dash, is defined as mu r dash, that is equal to expectation of x minus a whole r, where a is a real number. Okay. So let's start writing it. The topic is moments of a random variable. Moments of a random variable. Okay. Subtopic. So what it is? Mu r dash, the rth moment of a random variable. We are finding out the rth moment so that then you can easily calculate the first moment, the second moment, third moment, fourth moment, and so on. Okay. So the rth moment of a random variable capital A is denoted as mu r hyphen mu r dash, that is equal to x minus a whole to the power of r, then expectation of that mu r dash, that is equal to expectation of, first you are going to find out x minus a whole to the power of r. Okay. Whatever be r is 1, then x minus a whole to the power of 1, x minus a whole to the power of 2, x minus a whole to the power of 3, so on. And whatever value you get over here, you are going to find out the expectation of that particular value. And this gives you the moment of, means the rth moment around this particular variable capital X. Okay. So the rth moment about 0 is, what is the rth moment about 0? Means if this capital A becomes 0, then what we get, mu r hyphen, that is equal to e, x minus 0 is 0. Okay. X whole to the power of r, this becomes the rth moment about 0. Now we find out another thing, the rth moment about the mean of x. The rth moment about the mean of x. Now let's calculate the rth moment about the mean of x. Mu r, that is equal to expectation of x minus x bar whole to the power of r. X bar means the mean of x. Okay. So rth moment about the mean of x is x minus x bar whole to the power of r. Then find out the expectation of this particular term. Again I repeat, mu r is equal to expectation x minus x bar, means x bar means the mean about x. Okay. Whole to the power of r, then find out the expectation of this term. This is the rth moment about the mean of x. Now we will be solving a problem. Now let's continue this in the next video because it is going to get too long.